Students, next we discuss about Coulomb's law first problem. Okay, so I am write the problem on the board. What is the problem? What happens force between two charges if the distance between them is A, halved, that is half, and B question is doubled. That means what is the force between these two charges when the distance between them is half and doubled? Okay, so first we know that the Coulomb's law formula answer is according to Coulomb's law we have to write the force between two charges F equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the force between any two charges. So he says that what happens to this force between two charges if the distance between them is halved and doubled. So first case we have to take A, question A is halved. That is, distance between them is halved. What is the distance? Distance is the R. We have to take charges Q1 and Q2. Initially they are separated by distance R. Now it becomes halved. That's why there are move with each other Q1 and Q2, and they are separated by distance is R by 2. Okay, so in this situation this force F1 equal to F, and in this situation distance R1 equal to R, initial case. Now the second case, the force F2 we will be find, and this distance R2 equal to R by 2. Okay students, you understand this problem and understood this concept? Okay, so that's why we have to write force is mainly in this situation it depends on distance, not charges and not 1 by 4 pi epsilon naught value. So we have to write these are all are constant, 1 by 4 pi epsilon naught and Q1 Q2 are constant, remaining F is varies with R. So that's why we have to write F is inversely proportional to 1 by R square. 1 by R square. Now we have to write this forces F2 by F1 equal to this inversely proportional value. So we have to write R1 by R2 whole square. Okay friends, you understood this one? And F2 by F1 is F, F1 is F, and R1 is R by R2 is R by 2, R by 2 whole square. Now in this situation we have to write this one R by R, and remaining 1 by 2 will move upward, that is 2R by R whole square. So that's why this R will get cancelled, then we can get 2 square, that is equal to 4. Okay, so finally F2 by F equal to 4. So we have to write F2 equal to this 4F. 4F. What happened? In first case, the distance between them is halved, then force between them is become 4 times of the initial force. 4 times of the initial force. That is, two charges are separated by some distance. The force between them becomes halved. Then these two charges, then the force between these two charges will be increased. Okay? So, that's why we have to write F is inversely proportional to 1 by R square. That means R will be decreased, then force will be increased. Okay, students, you understand this point. Now, in second case is also there, that is B. B is doubled. That is, distance between them is doubled. What happened? That's why, same as it is, in this situation, we have to write this F2 by F1 equal to R1 by R2. So, in this case, same, R1 equal to R, but R2 equal to double. That is, we have to write 2R. So, these two charges are moved away from each other. That is, this is Q1 and this is Q2. Then they are separated by distance. This force is F2. We have to find this F2 and R2 is 2R. Distance becomes doubled. So, that's why again we have to write this formula. Therefore, F2 by F1 equal to R1 by R2 whole square. That is R1 by R2 whole square. Once again, we have to write these R1 and R2 values. F2 by F1. F1 always F. There is no change. So, F by R2. R2 is, this F1 is F and R1 is R and R2 is 2R whole square. Okay. So, what happens? This R will be cancelled. Then which is equal to 1 by 2 whole square. 1 by 2 whole square means 1 by 4. So, F2 by F value is 1 by 4. F2 by F value is 1 by 4. So, that's why we have to write F2 equal to F by 4. What happens? What about in second case? The distance between them, these two charges will be double, then force becomes decrease with 1 by 4 times. Decrease with 1 by 4 times. Okay, students? So, in this also, distance will be increased, then force becomes decrease. Distance will be increased, force will become decrease. So, that's why force is always inversely proportional to distance of between these two charges. Okay? And we discuss the next problem. Students, next we discuss about second problem. What is the second problem? It is also a simple problem. What is the force between two small charged spheres? Charged spheres, balls. Having charges of one is 2 into 10 power minus 7 Coulomb and the second one is 3 into 10 power minus 7 Coulomb. Now, they are placed 30 centimeters apart in air. That is, in air, these two charges are separated by 30 centimeters in air. One is 3 into 10 power minus 7 coulombs. Second one is, first is 2 into 10 power minus 7 coulombs. And second one is 3 into 10 power minus 7 coulombs. Then we have to take direct formula for Coulomb's law. Okay. So, this Coulomb's law formula. What is the Coulomb's law formula? The answer is, according to Coulomb's law, the force of attraction and repulsion between these two charges of value of formula F equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the formula. This is equation number 1. In this formula, we substitute the Q1, Q2 and R values and also 1 by 4 pi epsilon naught value. We will get the force value. So, what are there? Given that, what is the force between two small charges? We find the force value, and these spheres having charges. One is 2 into 10 power minus 7 coulombs and second one 3 into 10 power minus 7 coulombs. That is, we have to write, given that Q1 gives 2 into 10 power minus 7 coulombs. Okay, and second Q2 is equal to 3 into 10 power minus 7 coulombs. Okay, so that's why we have to write these ones distance. What is the distance between these two charges? And they are separated apart in air. That is, the distance are equal to 30 centimeters. And this one will be converted to meter. Centi. What about centi value is 10 power minus 2 meters. 1 centimeter equal to 10 power minus 2 meters. You remember this one. So finally we have to write the formula. In the formula 1, force. From 1, this force F equal to 1 by 4 pi epsilon naught value. What is 1 by 4 pi epsilon naught value? Is 9 into 10 power 9 newtons. Sorry, Newton meter for Coulomb square. So that's why we have to write 9 into 10 power 9. This is 1 by 4 pi epsilon naught value. And what is Q1 and what is Q2? Q1 is 2 into 10 power minus 7. Q2 is 3 into 10 power minus 7 coulomb. So we have to write Q1 2 into 10 power minus 7 and Q2 is 3 into 10 power minus 7 by what the value? R square. What is the value of R? R is the 30 centimeters or 30 into 10 power minus 2 meters. So that's why we have to write 30 into 10 power minus 2 whole square. What happened? Now the square will be taken. Then what is the next one? Is F equal to 9 into 10 power 9 into 2 into 3, 6. That is 6 into, this is 10 power minus 7 and this is 10 power minus 7. Then what happened? 10 power minus 7 and 10 power minus 7 is 10 power minus 14 by 30 into 10 power minus 2 whole square. 30 whole square is 900. 900 into 10 power minus 2 whole power 2. That is 10 power minus 4. Okay. So that's why we have to write this 900. So F equal to 10 power 9, that is 6 into 10 power minus 14. That is 6 into 10 power 9 into 10 power minus 14 by 100 into 10 power minus 4. What happened next one? F equal to 6 into 10 power 9, 10 power minus 14. Minus 14 plus 9. What is value? 10 power minus 5. And in this case, lower section 100 is 10 power 2. This is 10 power minus 4. Then what happened? 10 power minus 2. Okay, so 10 power minus 2 and minus 2 is will get 3. Therefore, F equal to 6 into 10 power minus 3 newtons. Okay, so we have to say that two charges, one is 2 into 10 power minus 7 coulombs, 3 into 10 power minus 7 coulombs. They are separated by distance 30 centimeters in air. Then force between them is 6 into 10 power minus 3 newtons. 6 into 10 power minus 3 newtons. Okay. So, this type of problems are given your IPE public examination, and this problem will come in comes also in March 2019 by 4 marks problem. Okay, so very important problem this one. Thank you.